Imagine a world, okay? A world totally encased in ice. But under that frozen surface, there's an ocean. An ocean that might be, just might be, teeming with life. We're talking about Europa, one of Jupiter's moons. And it's got scientists, well, you could say they're a little obsessed, because Europa, it might just hold the answer. The answer to are we alone in the universe? Welcome to Cosmos in a Pod, by the way, our space and astronomy series. And today we're going deep, really deep. We're diving into the mysteries of Europa.
You know, what makes Europa so fascinating, really fascinating, is, well, it has several crucial elements. Elements we believe are necessary, absolutely necessary for life. Life as we know it anyway.
So break it down for me. Like, we're talking about a moon.
Right.
How big is this thing?
Think smaller, a little smaller than our moon. But it's got this, well, this incredibly unique characteristic. It's got a hidden ocean. Evidence, and there's a lot of it, suggests there's this vast, I mean truly vast, liquid water ocean under Europa's icy crust. And get this, it could hold twice as much water, twice as much as all of Earth's oceans combined.
Yeah.
Crazy, right?
Yeah. Okay, yeah, that's a lot of water. But how do scientists know? How do they know there's an ocean under all that ice? We can't just, like peek under there.
It's like a detective story, you know? You piece together these clues from different sources. And one of the biggest, the biggest clue comes from the Galileo mission. You've heard of that, right?
Yeah.
Well, it actually detected these magnetic field interactions, and they all point to a conducting layer, a layer beneath Europa's surface. So what is that layer? What could it be? Most likely a salty ocean. Makes sense, doesn't it?
Okay, so we've got the data. This isn't just, like some guess. But is there anything else? Anything else that tells us this isn't just some stagnant pool of water?
Oh, the surface. The surface itself, it gives us more clues. Think of it like a cracked eggshell. All those crisscrossing ridges, that chaotic terrain, all of that suggests movement under the ice. Something's causing the ice to shift, to crack, and the most likely explanation, the most plausible, it's an active ocean below.
Okay, so we're talking about this huge, potentially active ocean, but isn't Europa, incredibly far from the sun? Shouldn't this ocean be, frozen solid?
You're forgetting the power of tidal forces. Think about it. You know about tides on Earth, right? The moon's pull, its gravitational pull. Well, imagine that, but on a much, much larger scale. Europa's orbit around Jupiter, it's elliptical.
Yeah.
So that causes tidal flexing, constant flexing. And that flexing generates heat through friction.
So Jupiter's gravity is basically, it's like kneading Europa, keeping its insides warm enough to keep that ocean liquid. Mind-blowing. But is that all that tidal flexing is doing?
You're on a roll. You're catching on quick. It's not just heat. No. Scientists they believe that this heat could be powering, get this, hydrothermal activity on Europa's seafloor.
Hold on. Hydrothermal activity, we talk underwater volcanoes.
Similar, yeah. But think of it this way. On Earth, we have those deep sea hydrothermal vents, and life thrives there in the absence of sunlight. It's amazing. And the way they do it, the way they survive, is by using chemical energy from the vents. So it's entirely possible that Europa's ocean, it could have similar systems providing energy for life.
Okay, so we've got this potentially active and definitely warm ocean, but what about, the building blocks of life? Are those even present on Europa?
That's another piece that's falling into place, actually. So Europa's surface, it's rich in water ice, lots of it. And it probably most likely contains organic compounds. The ingredients, right? Yeah. The ingredients for life as we know it anyway. And those ingredients, they're delivered by comets and asteroids.
Okay, so we've got the ingredients. But what about that radiation? Isn't Europa bombarded with, intense radiation from Jupiter? Wouldn't that be harmful to any potential life?
You've hit a crucial point. You're absolutely right. The radiation from Jupiter it's a major challenge. It would sterilize the surface, make it impossible for anything to live. But that's actually what makes the ocean so intriguing. So any life at all would have to be below the ice. It would need to be shielded, protected from all that harsh radiation.
So it's like a natural bunker, shielding potential life. Okay, I get that. But how would it get energy down there in the deep, dark depths of that ocean? We think of life, well, at least on Earth, as needing sunlight. But that wouldn't reach that far down, would it?
This is where it gets really, really interesting. So radiation from Jupiter. On the surface, it's harmful. very harmful. But it just might play a role in creating energy sources for life in the ocean. So the radiation, it breaks down surface molecules. It creates what are called oxidants, like hydrogen peroxide.
Oh, wait a minute. Hydrogen peroxide, isn't that like, for cleaning cuts?
Exactly.
Yeah.
In high concentrations, it's harmful, very harmful. But in the right amounts and small amounts, it acts as a chemical energy source. Think of it like a battery. And this is why that exchange, the potential exchange between the surface and the ocean, is so fascinating, so incredibly fascinating.
So the very thing that makes the surface, totally uninhabitable, that radiation, that might be contributing to the habitability of the ocean.
It's one of the leading hypotheses, yeah. It's a delicate balance, but it really highlights how incredibly complex the factors are that could make life possible on Europa. We're talking about a world where the energy for life, the energy it needs, doesn't come from the sun.
No.
It comes from the planet it orbits.
It's incredible to think that, a moon orbiting Jupiter might be the key to finding life beyond Earth. But are there any direct hints, any clues, anything that points to the possibility of life on Europa?
There are a few intriguing hints, a few hints that have scientists pretty excited. One of the most significant is, it's the observation of plumes of water vapor, plumes erupting from Europa's surface.
Plumes, like geysers shooting out from under the ice.
Exactly. Think of them like windows into the ocean, into that hidden ocean. So those plumes, if that's a big if they're coming from that subsurface ocean, well then future missions could sample that ocean water directly without having to drill through miles and miles of ice.
Hold on. So we could analyze that ocean water and look for signs of life without even landing on the surface.
It would be huge, a monumental step in our search for life on Europa. It'd be like having a direct line to that hidden world, the world under the ice.
Okay, so I'm already picturing those headlines. Scientists discover evidence of life in Europa's plumes. But what about the surface itself? Does that tell us anything?
Oh, it does. Spectral analysis of the surface. It reveals the presence of salts and organic molecules, which suggests that there's a connection, an exchange between the ocean and the surface. It's like the ocean is leaving its fingerprints on the ice.
So we're not talking about, just a static ocean. It's dynamic, it's interacting. It's almost like it's alive.
Yeah.
Like a living, breathing world.
That's a great way to put it.
Yeah.
Europa. It's not just this ball of ice.
No.
It's a dynamic system. It's a system that's alive, and that dynamism.
Mm-hmm.
That's one of the things that makes it so incredibly intriguing in our ongoing search for life.
Okay, so we've got this vast ocean. We've got potential energy sources. We've got the building blocks of life. We've got those tantalizing clues from the plumes and from the surface composition. But are there any parallels here on Earth? Any environments on our own planet that could give us insights into, what life on Europa could be like?
Oh, there are. Think about the most extreme environments on Earth. Places where life exists against all odds. You've got deep sea hydrothermal vents where life thrives in the absence of sunlight. It's incredible. And then you've got subglacial lakes, like Lake Vostok in Antarctica. You heard of that one? Well, entire ecosystems exist under miles of ice.
So if life can thrive in those incredibly harsh environments here on Earth, well, it's not so crazy to think that it could exist on Europa.
Right. Exactly. These are what we call analogs, earthly analogs. And they provide this framework, a framework for understanding how resilient life is, how adaptable it is. They expand our view. Of what's possible, and they give us hope that life might find a way, even in the seemingly alien world of Europa.
Yeah, it's a humbling reminder. Life might not always be what we expect. You know what I mean? Our Earth-centric view, it might be a little limited. And Europa challenges us.
Yeah.
Challenges us to think outside the box, think about what's normal. Normal for life, I mean.
Yeah, it's like a cosmic reality check. But even with all the positive signs, all the good stuff, I imagine there's got to be some challenges, right, for life on Europa. It's not exactly a tropical paradise. No, it's not. It's definitely not a walk on a warm beach. That's for sure. The cold, the extreme cold, that's a major hurdle. I mean, the surface temperatures, they average around, let me see, minus 160 degrees Celsius. So the ocean, yeah, the ocean's liquid. Tidal heating keeps it liquid, but anything living there, anything at all, would have to be, well, it would have to be adapted to some seriously frigid conditions.
So we're talking about life that thrives in freezing temperatures, not just tolerates them.
Yeah.
Are there any other challenges besides the extreme cold?
The radiation, we talked about that, right? That intense radiation, it's a double-edged sword. On the one hand, it could provide energy, but it's also a threat. It's a major threat. I mean, it sterilizes the surface. So anything living would have to be under the ice. Shielded from that constant bombardment.
Yeah, double-edged sword. It could give life energy.
Yeah.
But it could also destroy it. Makes you wonder how anything could survive, how it could find that balance.
Exactly. And then there's another big unknown, ocean chemistry. We think that Europa's ocean, it contains salts, but the exact composition, the exact recipe, it's still a mystery. And understanding that composition, understanding that recipe, it's crucial for figuring out if it can support life.
So it's not just about having water. It's about having the right kind of water.
Right.
The right mix, the right chemical soup for life to emerge, to thrive.
Exactly, precisely. And that's where missions to Europa, they come in. They're our best hope of cracking this case wide open.
Okay, let's talk about those missions to Europa. Haven't there been past missions that have, gathered some data?
Oh yeah, definitely. The Galileo spacecraft. It orbited Jupiter from 95 to 2003, a long time, and it provided the first real detailed evidence of that subsurface ocean. And then you've got the Hubble Space Telescope. It's been watching from afar, observing those plumes, those water vapor plumes, and those surface features, and it's given us some really valuable insights.
Okay, so those were like the opening acts,
right,
the warm up. But I've heard there's some really exciting stuff coming up, like the Europa Clipper. What can you tell us about that? What's the deal with the Europa Clipper?
Oh, the Europa Clipper. It's scheduled to launch, in 2024. It's specifically designed to answer some of those big questions, the big questions about Europa's potential for life, and it's going to revolutionize our understanding of this icy moon.
Okay, so what's on the agenda for the Europa Clipper? What kind of data is it going to be collecting? What's it going to be doing?
Think of it as a high-tech detective. It's got all the tools, a whole suite of instruments ready to investigate. It'll be doing flybys, multiple flybys, analyzing the surface composition, mapping the ice shell, figuring out how thick it is, and searching for signs of hydrothermal activity. It's going to be busy.
So it's like we're sending a robotic emissary to check things out, to scope out the place, and send back the intel.
Right.
But are there other missions in the works?
There is the European Space Agency, the ESA. They're launching their own mission. It's called GEOIC, the Jupiter Icy Moons Explorer.
GEOIC, huh? Okay. What's GEOIC going to be focusing on? Is it going to be investigating Europa too?
JUICE is going to be taking a broader look. It's going to be looking at the whole Jovian system, so not just Europa. No, it'll be checking out Ganymede and Callisto, those other icy moons. It's going to give us a lot of data, comparative data, so we can understand the unique characteristics of each moon.
So it's like a grand tour, a grand tour of Jupiter's icy entourage.
Oh,
that's cool. So we've got these missions, these incredible missions planned to study Europa in more detail than ever before. Feels like we're on the verge of some major breakthroughs.
Right.
But are these just the first steps? What about the future? The future of Europa exploration?
Now you're thinking long term, and that's where it gets really, really exciting. It would be challenging, very challenging, but there are proposals for landers that could touch down on Europa's surface. Imagine that, analyzing the ice directly, maybe even finding evidence of past plumes.
A lander. Yeah, that'd be amazing. Like sending a scout to gather that firsthand information. But what about going even further? What about exploring the ocean itself
Yeah.
directly?
That's the dream.
Yeah.
The ultimate goal, to get through that shell, that icy shell, and explore the ocean directly. There are concepts being developed for probes that could melt or drill through the ice. It would open up a whole new world, a whole new realm of exploration.
Wow. Sending a probe into Europa's ocean. It sounds like science fiction, but it would be revolutionary. I mean, imagine the discoveries waiting to be made in that alien ocean.
Yeah.
But what are the challenges? What would it take? What would it take to actually make that happen?
It would be a huge undertaking technologically,
Yeah.
financially. It would be massive. We're talking about developing, about deploying a probe that can withstand the pressure, that incredible pressure, and the cold, those frigid temperatures, and it would have to navigate an underwater environment, an environment we know nothing about, millions of miles away.
It's a daunting challenge, but the payoff, the potential payoff, it would be immense. Imagine the data, the images, the possibility of finding life. It would be worth every ounce of effort.
It would be a defining moment in human history, and it wouldn't just be about the scientific discoveries. No, it would be about the spirit of exploration, about dreaming big, about that relentless pursuit, the pursuit of knowledge, the pursuit that defines us as humans.
It's inspiring, really inspiring. But let's bring it back to the present for a minute. What are the big questions? The big unanswered questions, the questions that scientists are still grappling with when it comes to Europa.
The most basic question, the question that drives everything: is there life? Is there life on Europa? We have clues, tantalizing clues, but we don't have proof. Not yet.
It's the ultimate cliffhanger.
Right.
We've got this world with the potential for life, but we don't know. We don't know for sure if it's there. It's enough to keep you up at night.
And it's not just about finding, any life. No, it's about understanding what kind of life might exist. Are we talking about microbes, simple organisms, or could there be something more? Could there be more complex life forms thriving in that hidden ocean?
Yeah, finding any life beyond Earth, that'd be groundbreaking. Yeah. But finding complex life, that would change everything. That would rewrite our understanding of biology. Yeah. Of evolution. What other mysteries are hidden under that icy shell?
The ocean itself. We still don't really know much about it. The dynamics, how it works. We don't know how thick the ice is, the ice crust, or how it interacts with the ocean. Understanding those interactions, it's crucial for understanding the habitability of that ocean.
It's like trying to understand this hidden ecosystem, piecing together clues from very limited data. What about hydrothermal activity? We talked about those vents on the ocean floor. Is there any way to know if they're active and what role they might play, in supporting life?
That's another piece of the puzzle. Hopefully future missions, they'll help us figure that out. Are they active? Are those vents spewing out chemicals that could fuel life? What kind of ecosystems might exist around them? These are the questions that keep astrobiologists up at night.
So we've got the mystery of life itself. We've got the dynamics of this hidden ocean, and we've got the tantalizing possibility of hydrothermal activity.
Yeah.
It sounds like Europa is a treasure trove of scientific questions, just waiting to be answered.
It really is. Europa it's a compelling example of how life might exist in environments that are totally different from our own. It's a world that challenges us, challenges our assumptions, and it expands our imagination.
It reminds us that our understanding of life is, it's limited by our experiences here on Earth. There could be a whole spectrum of life out there that we haven't even begun to imagine.
And that's what makes exploring these other worlds so essential. It's about expanding our horizons physically, intellectually.
Speaking of expanding our horizons, Europa isn't the only place in our solar system, right, that has the potential for life.
Oh, absolutely not. Absolutely not. Europa's it's a front runner, but it's not alone. There are other celestial bodies out there in our solar system that have astrobiologists. Well, they've got them pretty excited.
Okay, so tell me more. What other worlds are on the on the astrobiology hit list?
Enceladus, it's a moon of Saturn. It's one of the most intriguing. It's got, just like Europa, it's got a subsurface ocean, and we've actually seen them, plumes of water vapor erupting from its south polar region.
So we've got direct evidence of water, and maybe other stuff too, being ejected from Enceladus's ocean. That's incredible.
It is. And those plumes contain organic molecules, which is, that's another good sign, another promising sign. It suggests that the conditions in Enceladus's ocean, they might be favorable for life.
So icy moons with subsurface oceans, they're becoming like the hottest spots for astrobiologists.
They are. They've got this unique combination, of factors that could make them habitable, even though they're so far from the sun.
It's amazing, just amazing how life finds a way, even in the most unexpected places. But are there any other contenders in this cosmic search for life?
Titan's it's a moon, Saturn's largest moon. It's a strange world, a fascinating world, with a dense atmosphere, and get this, methane lakes on its surface.
Wait a minute, methane lakes. That sounds like something out of a movie. Out of a sci-fi movie.
It does, doesn't it? It's the only place we know of, besides Earth, of course, that has stable bodies of liquid on its surface. Now those lakes are made of methane and ethane, not water. But there's still a chance that some form of life could exist there. Who knows? So
even though Titan's environment is totally different from ours, we can't rule out the possibility of life.
We can't. Life might take on forms that we can't even imagine. We need to keep an open mind when we're exploring the other world.
Yeah, it's a good reminder that our understanding of life is, it's limited. It's limited by what we know here on Earth. We need to be ready to be surprised by what we find out there.
Exactly. And that's why exploring these other worlds, it's so crucial. It challenges our preconceived notions, and it forces us to broaden our definition of what life could be.
It's a cosmic adventure, pushing the boundaries of our knowledge, the boundaries of our imagination.
I couldn't have said it better myself.
So we've got Europa, we've got Enceladus, we've got Titan, all these incredible worlds with the potential for life. It's almost overwhelming to think about.
It is. It makes you realize that we're living in a remarkable time. We're on the cusp of discoveries that could change everything, change our understanding of the universe and our place in it.
Yeah, it's a privilege to be alive to see these discoveries unfold.
It is, and it's a reminder that there's still so much out there to explore.
Speaking of exploration, are there any specific missions planned to investigate these other worlds, these potentially habitable worlds?
Absolutely. There are several missions in development or being proposed that will target these intriguing celestial bodies.
Okay, give me the scoop. What missions are on the horizon?
Enceladus. There's a mission concept. It's called the Enceladus Orbolander. NASA's looking into it.
The Enceladus Orbolander. Okay, what's so special about that one? What's it gonna be doing?
It's a 2-in-1 mission. It's got an orbiter and a lander. So the orbiter is gonna study Enceladus.
Yeah.
the distance. And the lander's actually it's gonna touch down on the surface and analyze that material. The material ejected from those plumes. Pretty cool, huh?
So it's like having a double dose of exploration, getting data from orbit.
Yeah.
And from the surface. That's impressive.
It is. And the lander's designed it's designed to search for signs of life. So it's a pretty exciting mission.
Yeah, it sounds like it could be a game changer.
Yeah.
A game changer for our understanding.
Mm-hmm.
Our understanding of Enceladus and its potential. Its potential for life. What about Titan? Any missions planned for that strange world?
There is Dragonfly, NASA's Dragonfly mission. It's set to launch sometime in the 2030s.
Dragonfly. Oh yeah. That's that drone thing, right? That drone-like spacecraft.
That's the one. It's a rotorcraft lander. It's gonna fly through Titan's atmosphere, that dense atmosphere, and explore those landscapes, those diverse landscapes.
So it's like a drone, but on another world. That's
Yeah.
That's amazing. So what's Dragonfly going to be doing? What's it going to be doing on Titan?
Dragonfly can visit different locations, take samples, analyze the surface composition in detail. It's gonna be our eyes, our ears.
Yeah.
On this alien world.
Okay, so what are scientists hoping? What are they hoping to learn from Dragonfly's explorations?
One of the key goals is to understand Titan's prebiotic chemistry. So the chemical processes that might have led to the origin of life, you know.
So it's not just about looking for current life. It's about understanding the conditions that might have allowed life to arise in the first place.
Exactly. Titan's like a time capsule. It's
Right.
preserving conditions that might have been similar to early Earth. So by studying Titan, we can learn about how life might have originated on our own planet.
That's a fascinating way to look at it. It's like looking back in time to understand our own origins. It's pretty mind-boggling.
It is, and it shows how connected everything is, our solar system, and the importance of exploring these other worlds to understand our own. It really makes you think, doesn't it? You know, when you look up at the night sky, all those stars, and you realize how vast, how incredibly vast space is, and how much we don't know. It really puts things in perspective, doesn't it? Our little problems here on Earth.
Yeah, it does make you realize that we're all in this together.
Right.
Not just us humans, but all of it, all of life. We're part of this big cosmic, I don't know, tapestry. It makes you want to take care of our planet, work together, solve those problems. You know.
Absolutely. We're all crewmates on this spaceship Earth, hurtling through space together. And the crew keeps getting bigger as we learn more about our cosmic neighborhood and the potential for life beyond our planet.
Speaking of life beyond Earth, it feels like we're close. We're on the brink of some major discoveries. What breakthroughs are you most excited about in astrobiology?
The possibilities are incredible. I mean, imagine finding evidence of microbial life on Mars, or maybe even something bigger, something truly amazing on Europa or Enceladus. It feels like we're getting closer and closer to that moment when we finally know, we finally confirm it. Life beyond Earth.
Can you imagine the headlines? Scientists discover evidence of life in Europa's ocean. It would change everything, wouldn't it? Our understanding of the universe and our place.
It would be a paradigm shift.
Yeah.
We wouldn't be alone. We would know that life is out there, that it's found a way to exist in environments that are totally different from our own. It would spark so much research, so much exploration. We would want to know everything. everything about these alien life forms, how they evolve, their biology, how they survive in those extreme environments.
It would be like opening a new chapter in the book of life, expanding our definition, our definition of what's possible.
Mm.
Do you think a discovery like that would bring us together, as humans, knowing that we're not alone in the universe?
I think so. Yeah, I think it would. A discovery that profound, it would transcend our differences. It would remind us that we all share the same origins, the same destiny as inhabitants of this cosmos. It would highlight how precious life is and how important it is to protect it, to preserve it on our own planet, and wherever else it might exist.
It's a reminder that we're all connected across cultures, across continents, across planets, maybe even across galaxies.
It is a profound thought, isn't it? The idea that we might be part of this web, this vast cosmic web of life, connected in ways that we can't even begin to understand.
It fills me with awe and wonder. It makes you realize that exploring these other worlds, it's not just about science, about curiosity. No, it's about understanding our place in the grand scheme of things. It's about those big questions, the biggest questions, the questions that humans have always asked.
Exactly. Are we alone? What are the limits of life? How did it all start? How did life arise? These are questions that have driven human curiosity for centuries. And it seems like we're getting close. We're getting close to some answers.
It's humbling. and exhilarating to be part of this journey of discovery. It reminds you that there's still so much out there to explore, so much we don't know.
And that's what makes it so exciting. The universe is full of mysteries waiting to be unraveled, and we humans, we have this incredible opportunity to be a part of it, a part of that grand adventure. It's a privilege and a responsibility to keep pushing the boundaries of knowledge, to keep exploring, to keep asking those big questions.
Well, we've covered a lot today, from Europa's hidden ocean to the possibility of life on other worlds. It's been an amazing deep dive into astrobiology, and I have to say I'm leaving this conversation feeling pretty hopeful.
Mm-hmm.
and excited about the possibilities that lie ahead.
It's been a pleasure sharing this with you. It's these conversations that can inspire others to join us on this incredible journey, of cosmic exploration.
And to our listeners, thank you for joining us.
Yeah.
Joining us on this cosmic adventure. If you're as fascinated by the search for life beyond Earth as we are, be sure to follow Cosmos in a Pod, and subscribe to our YouTube channel for more deep dives into the wonders of the universe.
Until next time, keep looking up and keep exploring.